Hello students, today we are going to solve a question from GATE 2023, and this question basically asks from that atomic physics, also young double slit. It's a mixed question. Okay, so in that question, let's write that question number. Question number 54. Okay, so in that question it is given that different spectral line of Balmer series falls on a young double slit experiment setup. So different Balmer series, different spectral line of Balmer series they have given from n to 2, that is false on young double slit septum. Okay, where n is the principal quantum number, and that can take values 3, 4, and so on. And also it is given that d is the separation between slit. D is the separation between slit S1 and S2. And they said that separation between screen and slit, that is constant. So if I take that symbol D, that representing basically separation between slit and screen. And it is mentioned that it is fixed. Okay. So now question is, it is asked that what should be the multiplied factor of D, small d, to maintain the constant fringe width. What should be the multiplied factor of D to maintain constant fringe width? Okay. So as we know that the fringe width is defined as, if I solve that question, the fringe width beta is defined as separation between two successive bright fringes or two successive dark fringes, right? Separation between two successive bright or two successive dark fringes. And that value used to come, or that expression used to come d lambda by d. Okay. So in order to keep that fringe width beta constant, we have to keep this factor constant. And the question already it is given that this d, capital D, is constant or fixed. So to fix this or to maintain this beta constant, it is already constant is given. So we have to maintain constant value of lambda by d. We have to maintain constant value of lambda by d. Now, if we apply that Bohr's theory, then we know that 1 by lambda or reciprocal of wavelength of emitted photon or wave number of emitted photon, that I can write for, especially for hydrogen atom, I can write R into 1 by 2 chi square, the final state, minus 1 by initial state. Where R is Rydberg constant, that is constant, right? So now from here I'll get the value of lambda, and that will be 4 n square divided by R into n square minus 4. Okay. So this will be the value of lambda, right? 4 n square by R, where R is the Rydberg constant, into n square minus 4. Now, if I substitute this lambda in this expression, then I'll get that fringe width beta, that will be d into 4n square by r into n square minus 4, and of course divide by lambda. So I can see that beta is a function of now principal quantum number. So to maintain this value constant, lambda should be multiplied by this factor. So if that lambda is multiplied by this factor, then since r is constant, so if lambda is multiplied by by 4n square by n square minus 4, then what will happen if I take, suppose if I take that value lambda is something constant into something constant k into 4n square minus divide by n square minus 4. Now if I substitute these values here, okay, then what will get d divided by d into 4n square divided by r n square minus 4 divided by k 4n square minus 4n square by n square minus 4. So this will be cancelled, and I'll get beta, that will be constant, d by rk. R is constant, k is constant, right? So that according to that given option, that option C will be correct. So lambda should be option C will be correct. Okay. So lambda should be multiplied by 4n square by n square minus 4. Okay. Thank you.